Thank you. It's actually along the lines of what you have already been asking, so I'll just continue it. You know, one of the things that we face this challenge with today when you talk to the everyday man or woman on the street is, well, why are we spending all this money at this time in our history on these things when we have so many other needs? And I think one of the answers to the question is what you've been talking about today, is all these innovations that are only possible in that setting. So we've talked about vaccines, you talked about bone loss and other, what other kinds of, I think this is for the whole panel, what other kinds of such, advances, whether it's for commercial and consumer application or health application, what other kinds of exciting things are happening up there in that setting that justify these expenditures, which allows us to get people excited about space travel internationally, but also domestically?
I'll punch the button on the microphone again. If you look at fire and its either discovery or learning how to tame fire is what literally brought us out of the cave and allows us to have our civilization in terms of what we know now. Fire gives us our electricity. Fire allows us to have vehicles, airplanes, and cars, and machines. It literally turns the wheels of our civilization. Fire has, and from a scientific point of view, we don't call it fire, we call it combustion. It has a strong gravitational factor to looking at what's going on in combustion. And we learn empirically that heat rises, right? And we learn that from fire. Fire goes up. Space station now offers us the ability to dissect deeper down into what the processes are in combustion that literally turn the wheels of our society by looking at it in an environment free from gravity, free from the gravitational-driven convection. And this allows us to look at things and figure out what's going on at a level that you could never see without taking it to space. And one experiment that I worked on space station, this last mission, was looking at solid air combustion and looking at it under lower convection, lower differential velocities between the air and the fuel that was being burned than what is possible on Earth because of the convection. And what we found is that things are more flammable than what we thought. That here on Earth, if you lower the convection to a certain point, the flame goes out. But in microgravity environment, we found that the combustion will continue at a state of lower convection than what we can actually go to here on Earth. And what the effect of that will be in terms of turning our wheels in our civilization, I don't know. But it's one small little step, incremental step in learning more about how this combustion process works.
Well, Senator, I'll just add that, when we look at it, again, is trying to develop new pathways and develop new kind of markets, if you will, for certain things. We kind of look at it in I would say almost 4 areas. We talked about life science, and in life science, I think there's just a vast number of things that we can do in life science. We talked about muscle wasting, osteoporosis, tissue generation, diagnostics, I think are really going to bloom in that area. Then we move over into material science. I think there's some very unique things that we'll see in the future in the areas of material science. Nano alignments, crystallization, different things that we can do by taking that gravity vector out. And then we move over into physical science and some others. But one thing that sometimes gets forgotten, and I look at it almost as a kind of a satellite guy, we've constructed basically the largest, most powerful spacecraft up there ever imagined. So with that sitting up there, we can do some really amazing things in Earth observation. We can put new instruments up there immediately almost, and we're working on some of those now with companies. This is a vehicle that passes most all of land mass every few days, and it's a great platform to do Earth observation. So, there's a plethora of things that are really there, and I think it's for us to kind of compartmentalize them, put them out, and then get out to those industries that can really utilize them.
Senator Rubio, I had last Saturday a 2-hour interview on a Saturday morning where I got a lot of phone calls that I had to answer that were exactly related to the question that you were just asking. Why are we spending so much money for that? And as Don just did, I think there is a lot of justification. Living in a world without gravity allows us to look into processes that help us to understand how life is functioning, a lot of physical processes and so forth, and that in turn creates certainly tangible benefits for society. However, and that I would like to add here, if we only look at those direct tangible benefits, I think we leave out an important aspect, and that is the fact that gaining knowledge, gaining insight into the surrounding is a benefit by itself, even if it is not immediately connected to, let's say, utilization here on ground. The aspect of exploration, which Don described, is one of these examples. If we fascinate our young people to get engaged in these STEM topics, I think that is also a benefit, which is maybe not directly tangible as maybe creating new materials or new drugs or vaccines that help us to fight diseases. But I think we always need to have the view on this overall benefit, the tangible and not the tangible ones. And last not least, I think the cooperation, the international cooperation, as I also stated before, is an important aspect of spaceflight. Working together in space is a very valuable asset. Thank you.
Just to add quickly, any physical phenomena that we have that has a little g in it, the gravity vector, when you take it to space and you remove that gravity, you get a different insight into that physical phenomena. And then that allows researchers and companies to potentially exploit that benefit like we've been discussing here in new ways we can't imagine. But it's tough to predict exactly where those breakthroughs are and exactly how they're going to pay back. But if they start, you could potentially start a whole new industry that never existed before. The other thing it does, I think, to Thomas's point, the intangible benefits, one thing is the creativity aspect. If you look at these student experiments that are flying up on the Japanese vehicle, the one student's experiment was to take a jumping spider and fly it into space. And this spider knows how to jump from one spot to another based on the gravity that affects the spider. So he knows exactly how to jump on his prey. What will happen in zero gravity, where he no longer has that gravity? Will this spider now learn and adapt to jump in a different direction as the humans do after a while? When they first get on space, I see these guys bump around, but then after a couple days, they're homed in on the zero-G phenomena, and they can float pretty effortlessly. Will this spider do that? But what was interesting is this student, in his own creativity, he imagined what this would be like, and he thought about a physical phenomena, a physical insect, and said, well, how will that perform? And that creativity and that ingenuity and that excitement in this student is just an amazing thing going forward. So how do you quantify that as being worthwhile?
What did the spider do?
We don't know.
Oh, okay.
Spider news this fall when he actually Sunita will do the experiment. So but that's the point. Is it's this inquisitive nature that really brings out the best in us and can really compel a nation to be exceptional.
Let us know about the spider when that happens. Now I'm
We'll
dying
do
to
that.
know. Thank you. That's great answers.